And now run your app and see if you see any pins appearing on the map. So, how many of you can see the pins? Perfect. And how many of you have got your driver in the lake? You got one, right? So the driver parked his truck by the lake and went boating. That's how you catch them. So sometimes you may see only you've got 7 drivers. If you've got 7 elements in that dictionary, even if you see less, let's say you're seeing only 5, it's possible that the random coordinates were too close to each other, so one is overlapping the other. That is a possibility. So you may sometimes see less. Or the other possibility is that one of them went slightly outside the area. See, I am seeing I've got 6 only here. So it's possible that one is on top of somewhere, one of them is covering the other. Okay, everybody up to this point. So our next stop is, if you click on one of these, what happens? If you click on any of these pins, you will see that the name is already there, the number will appear, the subtitle will appear. But what we want instead of that, so if there is a pin in Google Maps and other maps, what happens is if you click on something, you get like a bubble. So something that shows more information. This is called a call out. So we want to show a call out instead of showing nothing or just showing something below the pin. And call out have their own way of configuring. In MapKit, the default way of working with callouts is that it is divided into 3 parts: a left view, a right view, and a detail view. So, for example, let's say you're working with an app for restaurants. The left view could be the building, how it looks from the outside. The details could be where the address is, what the phone number is. And the right one could be a link to the website or something like that. So just an example. In our case, what we are going to do is we are going to just use the right one and put a call button here. So this call button will actually make a phone call. The way it works, when you're browsing on the phone, there is a phone number or a call button, you press it, your phone app opens, it does not make the call, but it has the number pre-populated, you have to press dial still. So that is what we are trying to achieve. So how do we get a call out? So at this point, what you would do is, if you don't know, you are going to go back to the documentation, do a Google search, etc. And you will find that there is a way to customize. So in your annotation section here, okay, this is the paragraph we were interested in. The presentation of annotation objects on the screen is handled by an annotation view, which is an instance of MK annotation view class. An annotation view is responsible for presenting the annotation data in a way that makes sense. So depending upon your application, it may or may not make sense. So whatever it is you choose, you decide what you're going to show. For example, the Maps application uses a marker icon to denote specific points of interest on a map. So like you will see that, in our case, they're all red balloons showing up here. these pins. In Google Maps, in other places, you will see like this, for example. This is some public, park or something. Different icons. There may be a shopping mall which looks different. A museums may all be, different. So that kind of thing. But what we are really interested in is this. The MapKit framework offers MK marker annotation view and pin annotation view classes for similar annotations in your applications. So what we will do is we are going to subclass one of these and then customize it. So we are going to subclass marker annotation view. This is what we are going to subclass. An annotation view that displays a balloon shaped marker at the designated location. Perfect. So how are we going to do it? In your view controller, scroll right to the end after all the lines, including the closing bracket, and declare a class here. Call it custom annotation view because we are customizing it. And we are going to subclass from marker annotation view. So as you start typing MKMAR, you will see this. Don't have to type the whole thing. When you see MK marker annotation view as a suggestion, keep on typing until you see that, and then you double click it. And then you place an opening bracket, curly bracket, and press enter, and it automatically places the closing bracket for you. This is what Xcode does for you. Okay, so this is what we have done. Now this one, we need to customize it. So what we need to do is we need to override. What does override mean? Method override. Speak louder, please. So override. So when you subclass, when you inherit from a class, that class may have functions that you can change their behavior. That is what override means. You are overriding the behavior that is there in the parent class. So which method are we overriding? We are overriding the init method. And as soon as you type init, you will see suggestions. Choose the first one. This one. Well, not the first one. You may see it in a different position. The one that says annotation and reuse identifier as arguments. Choose that. Okay, so it will receive an argument called annotation of this type and reuse identifier of this type. That's fine. The first thing we'll do is we'll do whatever the parent class does in its own initializer because we want to benefit from that. So the way you do it is you say super. Super is the same object, but now you are referring to the method in the parent class. Super.init. And we'll provide these same arguments. So super.init, this time I'm not getting the suggestion, so we'll go with annotation. Just pass the same arguments. Annotation and reuse identifier to the parent class. Okay. You will also see that you have an error, just like I do, called required initializer. Init coder must be provided by a subclass of MK marker annotation. So there are certain things when you are subclassing that parent class can define certain things that must be done in the child classes whenever you inherit. And in this case, it's asking for a required initializer of that type, the specifications. So click on this stop sign and say fix. And it will add this code to your class here. 3 lines of code. You don't need to do anything. It just says that this class has not been implemented. Not very helpful, but at least it got rid of the error. So what is this? Coder, decoder, NS coder. How many of you have heard the term serialization? Java serialization. So what happens is when you got an object, so the language in Java is called serialization, in Swift it's called coding, codable. What it does is you can dump that entire object onto the disk. So you save it. But then when you read it, you need to read it in a certain sequence and create your object. That is what this required initializer does. But because we are not saving it, we don't care about reading it either. But it is required, so we just provide an empty with some error inside it. So this is what this is. Okay, so now we have got an initializer where we can customize the thing. So the first thing is we want this thing, what we know as callout. So if you read the documentation, you will find that it has a property called can show callout. So we need to set it to true, otherwise the callout will not come. So self is the self object, this current object. Dot is, as soon as you start typing call, you will see can show callout will come up. So you just say can show callout equal to true. Perfect. So now we have said, okay, this annotation can show a callout. What else is it going to show? We said we want a button, right? How have we added buttons in other apps?
Just drag it from the library.
Exactly. So in this case, what is happening is that our view, see, in our main storyboard, we haven't got any callouts. We haven't got any pins. It's all being done dynamically. So we cannot drag and drop a button. So what do? We created program and we add it to it. That's what we do. So now we'll see how to create a button by writing Swift code instead of dragging and dropping, and how to customize it. Okay, so let's see how to add a button by writing code. So let's define a variable called button. What is the type of the button object? UI button. Press open bracket and it will give you 4 ways of creating a button. You can read it from the like this coder, decoder. By deserializing it, you can create an empty button and customize the whole thing. Or this third one is what we are going to use. You specify its frame. You specify its coordinates and its height and width. So choose this one, frame. And this frame is an object of type CG rectangle. So we will type that and press an open bracket and it will give us how to create. So we'll see a bunch of options, including one that takes 4 integers: x coordinate, y coordinate, width and height. So choose that one. Okay, and specify each number as, no, not each, x and y as 0. If we specify each as 0, we are saying height and width is also 0. Your button will never show up. But x and y 0 means that in whichever view you place it, that view has its own origin. Just like in CSS, how many of you are familiar with? When you say x0, y0, you're talking about the top left corner of the parent view. So that is what this x and y is, 0, 0. Top left corner of whatever view we are going to place it in. Let's say the width is going to be 40 pixels and the height is going to be 20. So that gives us a button, right? Now we need to specify what is going to be showing in the button. So we'll go with button dot set title. We said our button is just going to have one word in it, and it will be the word call. And this we have seen before. Buttons have states, normal, etc. How the button looks at any given time. So in Swift, you can actually change the text of a button. For example, when a button is touched, it's in the state, it's in a different state when it is than when it was not being touched. So you can have different text, different titles for this. So in our case, we just want it to be normal. So just go dot normal. So the title will always be call. Basically, that's what the button will say. And we'll set a title color. We'll make the button color. So if you say button dot set title, it will give you again a bunch of options. Choose the title color. This second one in my list here. And the colors, the UI color class is a bunch of static objects. So we'll say blue. And again, for which state, dot normal. So we'll make, and you can choose another color if you like. You don't have to go with blue. So this will give the button a text and a color. Now we need to add this button somewhere so that it shows, because right now it is just hanging in the limbo, not being added anywhere. So we will add it to this annotation. And like I said, every call out has three parts: left, details, and right. So we want to add this to the right. So how do we do that? We go self dot, let's type right and see what options. Right anchor, right call out accessory view. This is the one. This makes sense because it's going to appear as a view, accessory view in the call out. So double click this. And now equate this to the object you've just created, the button. Okay, run your app now and see what happens. To see any change. Who can see the button that we just added, the call button? Anything happening if you click on the pins? Same thing, right? Why is that? So we created this class. Did we create any object of it? Have we used it anywhere? So this code is not even being called. So now we need to tell this map view that all the annotations use this to build them. So how do we do that? So this for loop, right after the for loop, we will tell the map view to register this new class that we have created as the class to be used for all the annotations and the callouts. So start here, map view dot, and it has a function called, actually it's called register. So as you're typing mapview.reg, you will see this function. Don't need to type this. This is a very long string. You will definitely make typos if you type it yourself. So when it gives this suggestion, just double click it, register, and it will do this for you. Okay. So the first object is a class. So what is the class? This is the class name, custom annotation view, with the same capitalization as you created. Custom annotation view. That is not sufficient to say custom annotation view. If we are referring to the class name, we have to say dot self. That means the class name. Otherwise, it expects you to call a function, an initializer, or call a static function from that class. This way it knows that you're talking about the class name. The second object is for annotation view with reuse identifier. Where have you seen reuse identifier? In which app? That we have developed, you have seen this term before. Where did we have a reuse identifier? Yes. Tic-tac-toe, yes, but okay, good. Where in tic-tac-toe? Any further detail? You remember a function called DQ cell with reuse identifier? Some of you got those errors with DQ cell with reuse identifier. What cell? Table cell. So we had an identifier for cells. Here, annotations can be identified with the reuse identifier. So basically, let's say in your map, you've got one custom annotation view, which has a call button. What if you had 10 of these? One for the driver, one for the warehouse, one for the customer, and this and that, How do you tell the map that for this type of annotation, use this? That is where these annotation view reuse identifiers come in. And this is very simple. We actually don't need to give it any identifier here because we have got only one. So we'll use the default. So here if you say start typing mk map view, you will see a string called this is a string. It's a part of the same class. mk map view default annotation view reuse identifier. Annotation view reuse identifier is the key. Double click that. Don't need to type all this. If you type it, you're sure to run into issues. So just type the initial part, find this and double click it. mk map view default annotation view reuse identifier. And now you run it and see what happens. See now if your app in those pins, you can see the call button.
Yeah.
Yeah? What happens if you click the call button?
Nothing.
Why is that?
Because we
haven't told it to do anything, right? How did we do those in other cases where we had buttons? How did we tell the button that okay, when you are clicked, do this? IB action. We declare an IB action. So to declare an IB action there, how did we do that? What was our process?
just drag it and tell the button is clicked and do it.
Exactly. So you basically you have to code it, but we used to drag it. We had that ability because it was on the storyboard. Now this thing is not in the storyboard. So just like we customized it programmatically, we have to tell it programmatically what to do. Okay. So let's say that we create a function here. Let's call it make the call. Right? And because it's coming from a button, we'll specify a sender argument. So whichever button is clicked will be passed as an argument in this function. This becomes our IB action. But it is not as simple as putting add IB action in front of it because that won't work. We did not create it from the IB is interface builder. We did not build it in the interface builder. So we have to find another way. So this again, if you were to look for it, you would do a Google search how to set an action programmatically on the button and you will come to the answer. The answer is that button variable, you tell it that whenever the button is clicked, invoke this function, make the call. And this is how we will do it. So right here, after setting the title and title color of the button, say button dot, start typing add target and you will see this option. Target any object, any type, action, selector. So this action is what we specify as that function. So just double click it and you will get this code in place. So target meaning what will be passed as the argument. So in this case it is the self. Which object has the selector, right? So this, we are in this class custom annotation view, so it will call the function from the same object. And what is the selector? What is the name of the function? Now this has its own syntax, and you specify it using a hashtag hash selector. If you start typing hash SELE, it will give you the option, right? Just double click that, and then it has a method. So here we want to call this method make the call, and this is a method in, you have to specify class name dot method name. So the class name is custom annotation view, custom annotation view dot make the call. Oops, what did I do? And for the event, for which event, what events do we look for in buttons? What's the name of the event? Touch what? Touch up inside, exactly. So if you go here dot touch, you will see all the options with the touch, and what you want is touch up inside. That's the right way to do it. So it gives the user an option to remove their finger from the button if they change their mind after touching it. Then the up happens outside, so the event is not triggered. And at this point you should have an error here. And it says argument of hash selector refers to instance method make the call that is not exposed to Objective-C. Add at objc to expose this instance method to Objective-C. How many of you have heard of Objective-C? Objective-C was the first language in which you could develop iPhone apps. And the iPhone was first launched in 2007. That's when Objective-C, it became the standard language to create apps for the iOS platform. But then with years passing, Apple realized that it could be improved, so it created Swift, which is what we are using. Now Swift is sitting on top of Objective-C. So basically whatever we write in Swift, it appears that internally it gets converted into Objective-C and it functions like that. So to do things like this, to call a function, pass it around as an argument, we need to expose it to that internal framework. That is why it is complaining, and it is offering a fix. You don't have to do anything, you just click on the fix, and you will see that when I click on this fix, it will do exactly what it says here, add at objc. So it will add the keyword at objc in front of the function declaration there. Gone. So now it knows that it has to call this function, right? Let's for testing print a message here saying calling driver, although it's not doing anything right now. And now when you run the app and click on the call button, you should see in your debug output the text calling driver. You see it? Good. So let's see what I see. So when I click on this, I see the name of the driver, the phone number, and I can say call. And it says calling driver. Right, but it's not actually making the call. Now we have to implement the part where it is actually going to place the call. How do you do that?
Just pass the value as a temp.
Value as a temp. So you are all familiar with the concept of URLs, right? URLs are of various types. They begin with, most common that you have seen, they will begin with HTTPS or HTTP:// This is the protocol. And the other part is the address where it goes, right? What are the other protocols you are aware of? HTTP, HTTPS, so S is optional. What else? So www is a part of the address. In the protocol, you probably have seen one called mail to. What does mail to do? If you have a web page and you have a link and you give it this protocol, mail to somebody's email address, that's it, right? And if that is clicked, what it does is, does it open another web page? It opens your email program. Right? If you're on the phone, it will open your mail program. If you are on a desktop, if you use Outlook, for example, it will open Outlook. You can configure these days Chrome and Firefox to open your Gmail or something, but it will open something, which will allow you to compose a mail. Similarly, there is one protocol called TEL, telephone. So that behavior is the system knows that when you click on a TEL protocol URL, it needs to make a phone call.
FTP.
FTP is another one. Yes, we can. So FTP will open your FTP program. So what we need is to convert our phone number into a URL with the TEL protocol and ask the system to open that URL. And the system knows what to do after that. The iOS knows that it's a phone number. It will open the phone application and put the number in there. So how do we do that? So first we need the driver's phone number. Right? Now, what did we do with the phone number? Let's track it. In our model, we had the phone number as the value, the name as the key. Where did that go? In our for loop is where we are accessing it, and we are setting the key name of the driver as the title of the annotation and the value as the subtitle. So the phone number is the subtitle. So we will get it from here. Let phone number equal to, so the same annotation object, you will see that the initializer of this class is receiving an annotation object. It's the same annotation object. So you will go annotation dot subtitle. Let's create a URL from it. So it is complaining now, binary operator plus cannot be applied to operands of type string and string double optional, 2 question marks, and does not give us a fix. What does that mean? So why is it a double optional? It's because if you look at what this annotation object is, it is optional, and within that the subtitle is also optional. So there are a couple of possibilities. We could unwrap this one here, annotation. So if it is nil, the program will crash. And then unwrap the phone number here. So it is still considering it an optional. So basically it is giving us, now it is giving us an option. Force unwrap using exclamation to abort execution. So choose that and say fix. It's doing a double unwrap. Okay, so this gives us a URL string. It has provided us whatever the phone number was, it's got concatenated with tel//. Now we'll create a URL object from it, and we'll use conditional binding here, which means that you'll put the assignment of the URL object. See, URL object, the capital U, capital R, capital L, that's how you create an object in Swift. And when you press the opening bracket, you'll see a bunch of ways to create a URL object. Scroll down until you see this one, string, and double click that. So basically we are creating from a string. And this is where you will pass URL string. This variable here, you'll pass it here. And then what happens if this is true? So why did we have to embed it in an if? Why not just say let URL equal to that? Because URL object creation can fail if our URL string is malformed. So for example, if we make a typo in TEL and the system doesn't know what the hell you're talking about, or it has got some other mistake in it, TEL:// then another TEL or another HTTP or something is wrong, then it will not be able to create a URL, and then it won't go inside the if. We could put an else and print an error or whatever, show a dialog box saying there was a problem, etc. We're not interested in that. All we want to do is now use this URL object to make a phone call, basically to invoke it. So all that is remaining for us to do is now tell the system to open this URL. If it was a web page URL, it will open Safari. So for example here, if you say http://www.google.ca and you invoke, ask the system to open that URL, it will open it in Safari. You can try that. And how do you open a URL? You ask the application, UI application object, it has a shared object, and it has a function called open, and you just pass the argument URL to it. And now you run it and see what happens. So you run it and click on the call button, see if anything happens. Is it making a phone call? Is it opening anything? No, right? Okay, that's because the simulator has a limitation. It does not have the ability to make phone calls to run the phone app. If you were doing this on an actual device, you would see that the phone app opens. You could, for example, change this TEL. Let me just show that as a demonstration. I'll change this to HTTPS. See, right now I am still using the TEL here. Call does nothing. Nothing, right? Now I have changed it to HTTPS. Let's see what happens. Does it try to open a website? Right, so I'll click this and I'll say call. It has opened Safari and searched for that. So that's what that function call does. It opens a URL. You could say mail to. You could send an email to the driver. You could use SMS, texting, whatever protocol texting requires. You could say that, and it will open your messaging app.
So using telephone, it will open the phone app and then it will start making.
Yes. So.
But it doesn't have the limitation.
Yes. So the simulator does not have the ability to make phone calls or the phone app even. Right? So that's why it doesn't come up. But that was what you needed to do, TEL. Now, also, even if you had the phone app, it won't make the call. What it will do is it will open the phone app and put the phone number there. You have to press call. So that is again a safety feature. Okay, so this is what your app is. What you can do is you can take a screenshot of your screen here. Okay, everybody got it working? Anybody having difficulties? Raise your hand, please. She has a lot of error. Okay, we'll fix them. So what I want you to do is take a screenshot of the simulator. How to take a screenshot? Okay, while the simulator is showing this, you can also do this. Take a screenshot like this, showing the call button and the call out, and then in simulator, go to file and say new screenshot. It will save on your desktop. Email it to yourself. I will open an assignment. You can submit it from anywhere. Okay. So just make sure you open this call out. Click on any of the balloons. You will see the phone number, name, and the call button, and then take the screenshot. So that's basically what we wanted to cover for today. Let me see what else is on the slides. So okay, so that's pretty much it. That's what we wanted to cover. Any questions? Any questions about today's class? Any questions about the project? Okay. All right, guys. So see you next week.